Hi, hello everyone. Welcome to SK Academy of Mathematics. Today let us learn how to solve the problem on linear combination where there will be a given set of vectors. Considering those set of vectors, we need to find the linear combination of these three set of vectors. How to find and how to verify? Now let us see. First, to satisfy a linear combination, always we need to represent the vectors. To represent the vectors, before that we need to consider the linear combination condition. What is the linear combination condition? That is solution. We know that the linear combination is given by C1, V1, C2, V2, etc. up to Cn, Vn, which is equal to V. Now, what is this V1, V2, V3? These are up to etc. Vn. This we call it as the vectors. And V is also the condition that we need to show. Okay. What are these next comes? C1, C2, Cn. These are called as scalar vectors. That is what we are going to find. That is C1, C2, C3. Now we have how many set of linear combination we are going to consider? We are going to consider three set of vectors and we are going to find three set of scalars. Consider V, which is equal to C1 V1 plus C2 V2 plus C3 V3. That is V1, V2, V3. This will be our V. Okay, let us represent V, which is equal to 5, 9, 5. V1, which is equal to 2, 1, 4. V2, which is equal to 1, minus 1, 3, comma, V3, which is equal to 3, 2, 5. Now, represent these vectors in the given standard linear combination form, that is C1 into, what is V1? 2, 1, 4 plus C2 into V2. What is our V2? We have 1, minus 1, 3 plus C3 into V3 we have 3, 2, 5 and which is equal to V. What is our V? We have 5, 9, 5. Now multiply the scalars. That is 2C1, C1, 4C1 plus C2, comma, minus C2, comma, 3C2 plus 3C3, 2C3, comma, 5C3 equal to 5, 9, 5. Now, what I am going to do? I am going to convert this into three set of vectors. That is, I am going to add first term addition operation, which is equal to the first term. That is, first let us add the first term. 2C1 first term plus first term we have C2 plus 3C3. Next, let us add the second term. What is our second term? We have C1 plus into minus C2 plus 2C3. Next, we have 4C1, third term. That is 4C1 plus 3C2 plus 5C3, which is equal to 5, 9, 5. Now, consider, see we have three set of vectors. Considering these set of vectors, we are going to represent it in the linear equation form. That is, first term equal to first term 2C1 plus C2 plus 3C3, which is equal to 5. Next we have C1 minus C2 plus 2C3 equal to 9. Next 4C1 plus 3C2 plus 5C3 equal to 5. Consider this as equation 1, equation 2 and equation number 3. Now I need to reduce this system of linear equation and find the scalars, that is C1, C2, C3, such that it should satisfy LHS equal to RHS for all the three conditions. How to satisfy how to find C1, C2, C3? That is by using Gauss elimination method. We solve the system of equation by Gauss elimination method by the representing into augmented matrix form. That is, now let us represent this what linear equation into augmented matrix form. Now what we are going to do, just we are going to consider the coefficient of these linear equations. That is, augmented matrix is represented by matrix A is to B. A represent the coefficients and B represent the constants. Now let us represent the coefficients. That is 2, 1, 3 is to 5. Next 1 minus 1, 2 is to 9. 4, 3, 5 is to 5. Now, what is our aim? I need to consider the system of equation by using Gauss elimination method. What does Gauss elimination method say? That is, below the diagonal elements, every element should be 0. That is 1, 4, 3. This is our main aim. So, how I am going to reduce? By using what? Row reduced echelon form. That is, first, I need to make this as 0 by using first row as constant. So what I am going to multiply? I am going to multiply 2 for the second row. That is, R2 dash changes to 2 times of R2 minus R1. Now, let us simplify 2, 2, 2, 2. R2 we have 1, minus 1, 2, 9, minus 2, 1, 3, 5. Let us use the calculator for the better simplification. Now 2 minus 2 you get 0. Next we have 2 into minus 1 we have minus 3. Next 2 into 2 minus 3 we have 1. Next 2 into 9 minus 5 we have 13. That is, which is equivalent to 2, 1, 3 is to 5. First row will be constant. Next the second row elements we have 0, minus 3, 1 is to 13. Done. Now let us simplify the third row first element, that is 4. Let us simplify. R3 dash changes to R3. To get this to make this element as 0, I am going to multiply 2 for the first row minus 2 times of R1. Always remember, why we are not going to do with respect to second row means one row simplification should not be taken for the another row simplification. Whichever row we are going to consider it as a constant. Considering that row itself, we need to simplify the below rows. Now, so what is R3? We have 4, 3, 5, 5 minus 2, 2, 2, 2. What is R1? 2, 1, 3, 5, which is equal to 4 minus 4, 0, 3 minus 2, 1. Next, 3 2s are 6, we have minus 1. Next, 5 2s are 10, minus 5. 5 2s are 5 minus 10, minus 5, which is 0, 1, minus 1 is to minus 5. Now what we are going to do next? I am going to simplify. See, below the diagonal elements, this element have made as 0, this element we have made as 0. Now next we have 1. So to reduce this one, what we are going to do? R3 dash changes to, but 0 should not be changed. So I am going to consider with respect to R2 itself. If I go with respect to R1, 0 changes to minus 2 or minus 1. But 0 should not be changed. So I am going to simplify with respect to R2. R3 dash changes to 3 times of R3. Since we have minus, I am going to put plus R2, which is equivalent to, first and second row remains constant, is to 5, 0, minus 3, 1 is to 13. Now let us simplify. 3, 3, 3, 3, R3 we have 0, 1, minus 1, minus 5, plus, 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 what is R2? 0, minus 3, 1, 13. 0 into anything? 0. Plus 3 minus 3? 0. See, minus 3 plus 1? Minus 2. 5. Minus, see, minus 15, 5 3s are 15, plus 13. We have minus 2. That is 0, 0, minus 2 is to minus 2. Now, see, after reducing, what? By Gauss elimination method. By reducing, that is below the diagonal elements, every element should be 0. That is upper triangular matrix. We have find upper triangular matrix. After the reduction, we are going to represent this matrix into linear equation form. That is 2C1 plus C2 plus 3C3 equal to 5. Next, 0 C1 minus 3 C2 plus C3 equal to 13. 0 C1 plus 0 C2 minus 2 C3 equal to minus 2. Consider this as equation 1, equation 2 and equation 3. Anything multiplied by 0, 0. If I consider equation number 3, consider equation number 3. If you multiply 0 C1, 0 C2, you get 0. Minus 2 C3 equal to minus 2. Minus minus get cancelled, 2 get cancelled. C3 value is 1. Similarly, if I substitute, consider equation number 2 and substitute C3 equal to 1. What is our equation number 2? If you neglect 0 C1, we have minus 3 C2 plus C3 equal to 13. Minus 3 C2 plus 1 equal to 13. Minus 3 C2 equal to 13 minus 1. Then minus 3 C2 equal to 12. 3 ones are 3 fours are 12. See, next C2 which is equal to minus 4. C2 is our minus 4. Next we have, see, consider equation number 1 and substitute C2 equal to minus 4, C3 equal to 1. Yes? Now, what is our equation number 1? 2C1 plus C2 plus 3C3 equal to 5. 2C1 plus, what is our C2? We have minus 4 plus 3C3 we have 1 equal to 5. Next we have 2C1 minus 4 plus 3 which is equal to 5. 2C1 minus 4 plus 3 we have minus 1 equal to 5. 2C1 equal to 5 plus 1. 2C1 equal to 6. C1 equal to 3. 2 ones are 2, 3s are 6. Now we have find the scalars C1, C2, C3. Therefore C1 equal to 3, comma C2 equal to minus 4, C3 equal to 1 are the scalar vectors. Now, whether these scalar vectors are correct or not, how to verify? That is, consider this equation number star, or else we can simplify in this any three equation, either we can simplify in this. If LHS equal to RHS, that is, if I multiply the scalar, if I am getting 595, then our scalar vectors are correct. Now let us see, consider equation star. Consider equation star, that is C1 into 214 plus C2 into 1 minus 1 3 plus C3 into 3 2 5, which is equal to 595. Now let us simplify. What is our C1? We have 3 into 214 plus what is our C2? Plus into minus, we get minus 4 into 1 minus 1 3 plus C3 is our 1 into 3 2 5, which is equal to 595. Done. Now let us multiply 3 2 first term into first term. 3 2s are 6, 3 1s are 3, 4 3s are 12. Next, okay, if you this will be little bit complicated. Just multiply. 3 2s are 6 first term, minus 4 into 1 minus 4 plus 1 into 3 3. 6 minus 4, 2 plus 3 equal to 5. See, first term, that is satisfied. Now let us go with the second term. 3 into 1 3, minus into minus plus 4 into 1 4. Next, 1 into plus 1 into 2 2. 3 plus 4 7, 7 plus 2 9. Second term is also satisfied. Similarly, let us go with the third term. 4 3s are 12, minus into plus minus, 4 3s are 12 plus 1 into 5 5 plus 12 minus 12 get cancelled, the result is 5. See, LHS equal to RHS. This is the main conclusion part. This is how we are going to find the linear combination for the given set of vectors, that is what, C1 C2 C3. I hope you have understood this problem. For more videos, please do like, share and subscribe. See you in the next video. Thank you.